Okay, here's a weird one for you. What do high-tech electronics and a pond full of frogs have in common? I know, it sounds like the beginning of a bad joke, but it's actually the key to cracking a really tough engineering puzzle. Let's get into it. No, seriously, this isn't a riddle. The answer is actually a brilliant algorithm that was inspired by the surprisingly smart way that frogs hunt for food. It's the secret to solving a super tricky problem in digital signal processing.
So, to understand why on earth we'd need to borrow a strategy from frogs, we first have to talk about the engineering challenge itself. And it all comes down to something called a digital filter.
You might not realize it, but every time you stream music, hop on a video call, or even just listen to a podcast, you are using digital filters. You can think of them as these little invisible heroes of our digital world, constantly working in the background to clean up signals and get rid of all the static, noise, and other junk we really don't want to hear.
But here's the catch. Designing a perfect filter? Well, that is incredibly hard. It's a massive optimization problem. I want you to imagine you're standing in front of a huge mountain range, and someone tells you, go find the single highest peak. With millions, maybe billions of possible peaks, finding that one perfect spot, well, that gives you an idea of the scale of the challenge we're talking about here.
So how have engineers usually tried to find that highest peak? Well, the old methods have a really serious flaw. They tend to get stuck pretty easily.
Let's go back to our mountain range. A traditional algorithm is kind of like a hiker who just starts climbing the first hill they see. Once they get to the top, they look around, see they're higher than everything right next to them, and they shout, "I did it!" But they've only found a local peak, right? Not the highest one in the entire range. As the research paper points out, these old methods get trapped all the time and just fail to find the best possible solution.
And this is where things get really creative. If our computer programs are getting stuck, why not look for inspiration from the true expert in optimization? And by that, I mean the natural world, which has been solving these kinds of complex problems for literally millions of years.
And this isn't just some cool, fuzzy idea. The research is clear. Algorithms that are inspired by nature consistently find better solutions. They're often called mimetic algorithms. You know, just like a viral meme spreads an idea from person to person, these algorithms let different potential solutions share information with each other and learn from what's working.
And that brings us to the star of today's explainer, the shuffled frog leaping algorithm. The whole idea is just so simple and brilliant. We imagine our entire problem is a pond. Every possible solution is a frog. And the best possible solution? Well, that's the spot in the pond with the most food. The goal is simple. Let the frogs find the food.
So how does this virtual frog pond actually work? Let's break down the strategy of this little amphibious search party.
Okay, so first you have to set up your pond. Every single frog represents one possible design for our filter. Where that frog is sitting in the pond, well, that represents the filter's specific settings. The amount of food at that spot is basically its quality score. The better the filter, the more food there is. And here's the key part. The frogs are split into little teams, so they can share information and learn from their immediate neighbors.
The whole process is this elegant three-step dance. First, a frog tries to improve by leaping toward the best frog in its own little team. If that doesn't really work, it looks further out and tries leaping toward the best frog in the entire pond. And if it's still not finding a better spot, it just takes a random leap somewhere new. This last step is the secret sauce, you know. It's what stops the frog from getting stuck on those small hills.
Now, what's really brilliant is how the frogs leap. It's actually a two-stage process. In the beginning, the algorithm encourages big, bold, random leaps to explore the entire pond really quickly. But as it starts to find some promising areas, the leaps get smaller, more careful, more precise. It lets the frog zero in on the best possible spot. It's this perfect balance between broad exploration and detailed, fine-tuned searching.
So this all sounds great in theory, but does it actually work in practice? Well, the researchers put the frogs to the test, and the results, they're pretty darn clear.
So for one super common type of digital filter, the results really speak for themselves. This chart shows the fitness score, and all you need to know is that a higher bar means a better design. As you can see, the frog leaping algorithm consistently came up with a better filter than the traditional method.
And nope, that wasn't a one-off. When they tested it on a totally different type of filter, they got the exact same result. Once again, the shuffled frog leaping algorithm just plain found a better design. It works.
But honestly, this next part is the most impressive. They didn't just test it against the old methods. They actually pitted it against other nature-inspired algorithms. This table shows the error rate, so think of it like a golf score, where a lower number is better. The frog leaping method didn't just win, it won by a huge margin. Its error rate was almost twice as good as its closest competitor. The frogs officially outsmarted the swarms.
So what's the big picture takeaway from all of this? Well, it really comes down to one crucial trade-off. Being smarter isn't always the same as being faster.
The paper's conclusion is really honest about this. See, finding the absolute best answer takes time. The SFLA method gives you a much higher quality solution, but it takes more computer power and it takes longer to run. So an engineer has to make a choice. Do you need a good enough answer right now, or are you willing to wait a bit longer for the best possible answer?
You know, ultimately, this isn't just a story about filters and algorithms. It's a perfect case study in the power of what we call biomimicry. By just watching a simple process in nature, a bunch of frogs looking for food, engineers were able to design a smarter algorithm that blows its predecessors out of the water.
And that really leaves us with one final thought. If the way a frog pond works can help us design better electronics, what else is out there? What kinds of solutions to huge problems in things like logistics or medicine or material science are just waiting to be discovered? Maybe by watching an ant colony or a flock of birds or a forest ecosystem. The potential is just absolutely immense.